Okay, so today we're going to talk about heat transfer. So let's start by defining what this is. Heat transfer is heat for one, and transfer. So transfer is basically just motion. So now you can make a connection that heat transfer is the motion of heat. Heat is represented by Q, and motion. When heat is in motion, we represent it with a Q dot, saying that you have a rate of heat transfer. And heat always travels between two temperatures, where the temperature it's coming from is larger than the temperature that it's going to. There's three modes of heat transfer. We have conduction, convection, and radiation. So, what are these three? So let's begin with conduction. Conduction takes place within a solid or between two solid objects. So I'm just going to write solid to solid. Next we have convection. A little bit different. This goes from solid to fluid. And finally radiation, which is unlike either of these two. It's through electromagnetic waves. So now I'll give you an example of what these three are in one picture before we get to a more complex real life scenario. So I'm gonna draw here a pot, and this pot is on a stove, and it's getting heat. If heat is traveling this direction, that means this temperature must be larger than the temperature inside. And I'm going to say we have water inside. So that temperature is lower. Now, at this point over here, when the heat goes from the surface of the pan to the actual fluid, which is the water, it's a solid to fluid transfer. So this is convection. When the heat travels from outside, so along the surface of the pan to the handle, that's conduction, right? Because it's solid to solid. And then when the water leaves the pot, we have radiation through electromagnetic waves. So this picture basically gives you an idea of what this is. Now let's go to a real world example. I'm going to draw a wall here. Okay, wall. The temperature on either side is the same, and I'm going to call it ambient or atmospheric temperature, represented by T infinity. We have a heat coming in. Okay, so Q dot, heat's being transferred. It reaches this point. I'm going to say that's T1. And it leaves on this side of the wall. So this is going to be T2. However, according to this, T2 must be smaller than T1, so I'm going to put it down here. And we're going to say this is connected. So there's a temperature gradient. This temperature gradient is known as thermal conductivity, or K, the slope of this line. And it basically just depends on the area. Once this heat leaves from this surface to the outside, it's a solid to fluid transfer. So this is convection. And convection depends on a coefficient of convection. Who would have guessed? So this also depends on the area. Now, let's say we're not satisfied with that. We want to increase the rate of heat transfer. We want to cool this wall quicker. How do we do that? Well, we know that heat transfer happens quicker if we have more area. So let's just add area to this. We're going to add something called a fin. And what this does is that it adds surface area. So the heat comes in, right? It goes over here, correct? Now instead of coming out, like over here, it'll just travel right through. So it conducts through this material, and it convects from these surfaces. So there's additional heat transfer happening. And usually you see fins in something like CPUs in computer cases. So this was a concept overview of what heat transfer really is, and hopefully this will help. Thank you.